Hello guys and welcome to a Crysis2 PC game running on 8K resolution screen with the help of single Titan RTX video card and Intel Core i9 generation i9 9900K emulated as i5 9600K running at 5300 MHz per each core or 5.3 GHz per each core, 6 cores, 6 threads, and very aggressive DDR4 CL9 1T command 2400 MHz system RAM. So during this video I'm going to show you only 8K resolution, which is 16 divided by 9 aspect ratio, 7680 by 4320. Okay, we're going to run into the full screen no, because look like Crysis2 has some issues when I'm running it on 30 Hz 8K resolution screen, and this is because I'm using today the professional external video recording equipment. It's having the little screen and it's accepting the signal in 8K resolution at 30 Hz as maximum, and this is what I'm doing today. And somehow Crysis is struggling to run at full screen at 30 Hz. At full screen it's running 24 Hz if you don't have 60 Hz monitor. Hopefully this makes sense. I'm not sure why it's doing that, but during this video I'm going to show you two different presets. I'm going to show you high, and then which is the lowest possible preset, visual preset, and then I'm going to show you ultra visual preset, which is the maximum possible visual preset possible under the Crysis2 PC game under the DirectX 11 API. Okay, and as well as I'm going to use the advanced graphics on touch at high, whatever the preset is, and high resolution textures is yes. Okay, this is the origin Crysis2 PC game. Comes with the high resolution textures and DirectX 11 API, so you don't have to download it and install it. And in the end of this video I'm going to share with you my PC hardware information within the details, so stick around. In the end of the video I'm going to share all kind of tips and tricks and frequencies on my PC computer components and PC computer parts. Let's go ahead and get going, guys. I'm going to show you two levels. I'm going to show you some sort of like in tunnel kinda, but even in tunnel we're still going to have a lot of geometry. As you can see, it's going to be a lot of 3D meshes of the characters, but I really like the first level because we can use the half of the first level as our benchmark, because it's going to be 3D animation rendered within the game engine. It's not going to be pre-recorded 3D animation. And then the second chance, which is going to be the open world in Crysis2. So pretty much everything that you need to know during this video I'm going to show it to you. I'm commenting in real time. English is not my first language, but I was PC gamer, PC hardware enthusiast, PC overclocker since 1998, and I'm a graphic designer, 3D artist, software engineer, and system engineer since over 10 years experience, guys. So I have a lot of information to share with you. At the right top corner, as you can see, I have the display information system. I call it TOFFER, updated every second, self-explanatory. T stands for the temperature of the component, U stands for the usage or utilization of the component, F stands for the frequency of the component, and FR stands for the fan rotation of the component. Available at 100% only for the Titan RTX video card, not available for my CPU, because my CPU today is cooled with the all-in-one water cooling system by Corsair H150i Pro, which is the best $170 that you can invest towards the CPU cooler. As you can see, this submarine right now is rendered within the game engine, so we can use it as a benchmark, as well as the scene right now inside of the submarine will be rendered within the game engine. Okay, so I'm going to use it when I'm going to use this video for myself in 3-in-1 value, because I'm going to create a video about the DDR4 in PC games. DDR4 technology. It's going to be a video when I'm going to compare the higher frequency and the lower timings versus each other, and if this is making any sense. And then it's going to be a secondary video when I'm going to compare the cores on the CPU and how many cores you need, and it's going to be a beautiful video. It's going to be available over the iPlay4k.com, but I definitely going to use this video as an example, because right now I'm running very aggressive timing, CL9 1T command, which is unheard of timing for DDR4, 2400 MHz, and It's just unbelievable, guys, latency delay. It's just as shortest as possible, unheard of for DDR4. But in the end of this video, I'm going to share this information with you. Just stick around till the end of this video. As you can see, my GPU utilization right now is 99%. My CPU utilization is 21%, 23% overall CPU utilization at the right top corner. So the CPU utilization will never reach even the 50% at all. And I'm just running 6 core, 6 threads, and those cores and those threads are physical cores, which is avoiding any logical cores, which is the best result. So hyper-threading technology is disabled in the BIOS, and I disabled 2 cores because the i9-9900K comes with 8 physical cores and 8 additional logical cores through the hyper-threading technology. So I disable all the possible higher latency delays, and we don't need any logical cores. We just need the physical cores to have the maximum possible performance. Hopefully, guys, this makes sense. So this is how Crysis 2 PC game looks at high preset, which is the minimum, as you can see, preset, which pretty much there is almost no difference between the high and ultra, which is the maximum visual preset in Crysis 2. As you can see, we have some like particles breaking up in the water as well, and the fire or smoke is going to happen because I'm running today Crysis 2 PC game as original without any modes. It's fixable under the console when you're running 4K resolution and above to make sure that the radius rendering is not going to break up your particles. As you can see, the Crytek company in CryEngine 3 that powering Crysis 2 PC game is using kind of plain particles approach instead of kind of volumetric particles approach, like kind of like a spherish or boxy. They're using like a plane, and you can see that plane. You're going to see right now this kind of plane going to move, and you're going to see the square. And it's fixable, as you just saw under the in the water particles. It's fixable in the console, and I'm going to record a video how to do it, how to play Crysis 2 4K resolution and above in the beautiful visuals. It's going to be an individual video available for you over the iPlay4k.com or over the UHDking.com. As you can see, as we're moving our head, the particles in the water, those sprites, it's the particles, but it looks like it's a sprites. It's not actual the particles. It's like animated sprite. This is what I'm thinking. This is how the Crytek company took this approach, because it's kind of plain, as you can see. And on that plane, I believe they're using a texture instead of some sort of like spherish or boxy particles that giving you that volumetric feel to it. So look like Crysis 2 is not fully volumetric particle system, as you can see. So they're kind of cheating a lot. Again, this right now, this rendered with the game engine. It's not the pre-rendered video, which is nice. So we can use it as for our GPU architecture comparisons or any video comparisons. Guys, if you want to compare your results, please go ahead and bring your Crysis 2 into the windowed mode. And I know you probably will have no problem to run Crysis 2 with a 60 Hz monitor, but there is a problem with 30 Hz monitor because it's kind of switching to 24 Hz monitor, and if your monitor doesn't support this at 24 Hz, it's pretty much not going to render it. See that squarish kind of like that? This is the, I believe, the color correction sprite. As you can see, the color correction, you can see that squarish kind of thing. It's fixable, and it's just because the angle and the radius of the pre-render within the game engine. Look how beautiful the Crysis is looking. Even at high, look at this. In 2020, still one of the best looking games. And if you into the single players, if you don't like a lot of multiplayers, if you would like to play by yourself, single player, complete some missions, Crysis 2 is one of the best games. And this game right now is running below $9. You can just Google it, you can purchase it. It's a beautiful game. You're going to have a lot of fun. Great story. Great game with the Pixar-like animations, as you can see, in real time. And you playing it, so you don't have to watch like a cartoon. You don't have to watch pre-render stuff. You're just playing, and everything what is going on in the game, of course, you're doing it yourself, which is neat. So right now is the render with the game engine, but it's about to switch to a pre-render video. And when it's going to switch to a pre-render video, you're going to see that FPS will go above 600 FPS. and you will see that latency delay will go very low as well, like to 2 milliseconds, like right now. Right now it's using the pre-rendered video, and we want to avoid that. We're not going to bench it at all, so this is the just pre-rendered video. The GPU utilization is still high. There is a possibility it's preloading some data into the GPU while it's showing to us the pre-rendered video. Crysis2, Crysis3, and Crysis1 was using a lot of these approaches when they're showing us some animation pre-rendered video while they're preloading some data into the CPU, into the GPU, into the system RAM. Just the preloading level of details and the whole level. It's about to be over. Unfortunately, I cannot skip this animation. Pre-rendered video, it's not the animation, it's pre-rendered video. So we gotta wait a little bit, and then I'm going to show you that open world second level a little bit, and we're going to switch to ultra preset, the maximum possible visuals. So as you can see, Crysis2 on a single Titan RTX, which is the top dog Turing GPU architecture video card, and right now it's running completely stock, because you can overclock it the way you want it, but the maximum FPS throughout the overclock can be achieved 5 FPS, but average throughout the overclock you can gain about 3 FPS. Okay, I just don't want to overclock it. I just don't want to make it unstable or something like that, because I didn't test it yet, the maximum possible stable frequencies. So I decided to go ahead and show you guys completely stock performance, but keep in mind that today my Titan RTX is running on a liquid metal thermal compound paste on the GPU, and I'm running the IC diamond thermal compound paste on my VRAM, power distribution, and any single chip on the Titan RTX PCB. But I'm still using the Nvidia dual fan air heatsink design cooling solution, but I removed the Nvidia thermal compound solutions for the best industry solutions. So I reduced the about by 5 Celsius. We're going to find out exactly when I'm going to create a video comparison of the Titan RTX with the Nvidia thermal compound solution versus the best industry thermal compound solution that you can purchase for maximum $40 while they're repasting it. Because I have 2 Titan RTXs, and one right now is still running on Nvidia thermal compound solution, so it's going to be easier for me to test it just by switching it. But it's going to be individual video. I don't want to spoil you with a lot of information. So keep watching the iPlay4k.com YouTube channel, guys. Look at that beauty, guys. Look at that beauty. Wow. And we can use this as the game animation test as well, like a benchmark, because I cannot move my camera right now. It's kind of fixed, and everything is kind of fixed right now, so we can compare the FPS throughout the different benchmarks and test in the future. So whatever I'm going to use the Crysis2 benchmarks, I'm going to use my scenario, my approach that I'm using today, and I'm going to use my data, my video, to compare it against the different GPU architectures and against the different PC hardware. Okay, the game is still looking beautiful, guys. Unbelievable. Hopefully you don't hear the Titan RTX, that just I'm sitting close to it, and the case is open. So the case is open right now and it's running liquid metal, so this is the temperatures. But maximum on liquid metal, when I'm running just a single video card in my PC system, I'm going to reach 72 Celsius. This is the maximum temperature. So as again, I removed the secondary Titan RTX completely from the case to avoid any hot air pockets. Look how beautiful it is. Let me show you a little bit of water. Crysis2 is very famous in terms of the water. Underwater world, it's kind of looking great, rendered great, with the CryEngine 2, CryEngine 3, and CryEngine 5. Look at this. It's just beautiful. There is something is burning there completely. As you can see right there, like some sort of like a spherish kind of thing. As again, this is fixable, guys, through the console command, and I'm going to record a video to show you how to set your Crysis for 4K resolution and above. and this video will be available over the UHDking.com or over the iPlay4k.com YouTube channels. Go ahead and check it out. It's going to be great. As well, I'm going to show you the DirectX 11 API with 2 Titan RTXs, so keep in mind that our FPS can be double for sure. Let me show you a little bit of the action going on over here, and we're going to go ahead and switch it. Again, the purpose of this video is not the gameplay at all, because this guy is hiding. The purpose of this video is just to show you the performance. This is the main goal. Nobody, I don't think so. I don't think. Look at this. Let's go ahead and grab this dude. Here we go. And let's go ahead and put him into the water. Let's see, because the Crysis1 PC game under the CryEngine 2 had a beautiful. Okay, I just ran out of energy. Alright. Had a beautiful animation, the physical animation when you're putting something into the water. Let me see if this is possible. Let's go ahead and put this into the water. Maybe like a tire. Can we put the tire? Yeah, let's go ahead and have a look. Yep, it's still the physics right here. Water physics. This is breaking after some time, like after some timer, like in CryEngine 1, and stop bouncing. I'm just curious. It's still bouncing. Look at this. Into the water. Let me see. Is it going to still bouncing? Yep, it's still bouncing. Yeah, it's breaking under some timer, just like in Crysis1 PC game. It's like after like 15 seconds or 5 seconds, it's just breaking, and that's it. Look at this. Some more items appears. So they're using some timers. Alright guys, so let's go ahead and quit it now, and I'm going to switch the preset to the maximum possible visual. So you just look at 8K resolution, completely Titan RTX on stock, but the maximum overclock you can achieve 5 FPS if you're going to pay on it, because right now everything is overclocked except the Titan RTX video card. But average overclock will give you the 3 FPS to the right top corner. And as again, I'm not recording this video with the ShadowPlay or any other software. I'm recording with the professional external equipment, so the FPS is not taxing. The FPS will be just the same as I'm not recording, and the every single performance test will be just the same as I'm not recording. So ultra preset now. Accept that. Ultra preset over here. Accept that. Let's go ahead and reboot the level, and let's go ahead and check out the level. As again, using the same approach at ultra. Guys, I just cannot wait to show you 16K resolution, 4K resolution on the same computer, 6K resolution, which is the Apple 16 divided by 9 aspect ratio, Apple Pro display XDR monitor, and then 10K resolution, 12K resolution with all kind of different presets. It's coming under the Crysis2, Crysis 3, Crysis 1. I'm going to cover those 3 games with plenty of videos available over the iPlay4k.com, and hopefully even over the iPlay16k.com if Crysis 2 will be able to run with 2 Titan RTXs and SLI under DirectX 11 API in 16K resolution, hopefully.
So what's the word? Sit till we get orders to deploy. Kill us some bad guys. Suck it up, Marine. No
guys, I'm going to show you in the end of this video maxed out at ultra, not the maxed out, in the end of this video, because the ultra is probably not possible under DirectX 9. If it will be possible, I will show you ultra DirectX 9 API. If it's not going to be possible, then I'm going to show you high with DirectX 9 API instead of DirectX 11, just to show you all kind of different scenarios. So I'm going to provide you all kind of different information that is possible during this video, so I'm just going to cover the Turing GPU architecture at its best during this video. And as again, this is the top dog Turing GPU architecture video card, Titan RTX. But as you can see, even at 8K resolution, single RTX 2080 Ti video card can handle this, because the VRAM usage right now is 8,666 megabytes, and the single RTX 2080 Ti video card has 11 GB of VRAM, which is 11,000 megabytes. So it will have no problem to run it in terms of the VRAM, as well as when you're going to couple them to RTX 2080 Ti and SLI under DirectX 11 API. That's going to scale the SLI. You're going to receive a great FPS even at 8K resolution, even at ultra preset. It's going to be comfortable, kind of 30-ish FPS for sure, the lowest. Let's keep your eye at the VRAM usage. Right now is 8,800 megabytes, and the system RAM usage is very low, which is 5,830 megabytes. So I can definitely say that we are using the healthy VRAM usage. We're not overloading any data from our VRAM into the system RAM. And why should we? Because we have 24,000 megabytes is available for us for the frame buffer under our VRAM capacity. So we're Gucci over here. And as again, the Crysis2 PC game is running today without any mods. It's a original PC game from the origin, and it came with DirectX 11 API, as you can see, as the add-on, because it was add-on in the end of 2011, and with the higher resolution textures. There was also add-on in the latest, I believe, version 1.9 patch from the developers, the latest patch for this Crysis2 game, before they stopped supporting the game. So pretty much this is the maximum visuals ever. But you can add a lot of modes for Crysis2, and you can fix this type of squarish kind of rendering, as again, throughout the console commands and throughout the modes. You can even make it even on another level. So right now this is the render with the game engine. The camera rotation is fixed and movements. We are 22 FPS, and I know there is an Adrenaline Crysis2 benchmark, and some people will try to type, probably I should use that. The reason why I didn't use it, I installed that, and when I'm switching between the high and the ultra presets, the FPS are the same. So he's not switching the preset, so it's broken. So I decided to go ahead and show you myself, like kind of bench it myself with my approaches. But my approach is still Gucci, as you can see. It's a great approach because I'm using a lot of pre-rendered scenes that we can use as a static benchmark, because everything is the camera movement, the camera rotation is locked right now. Wow, for a second I saw 122 milliseconds latency delay. As you can see, our CPU utilization never reached even 50% on all our 6 physical and 6 physical threads, 6 physical cores and 6 physical threads. So pretty much we're receiving right now the maximum possible performance out of the Intel i9 generation CPUs. Look at this square at the left top. Oh my god, it's just such a horrible. And as again, it's fixable throughout the CryEngine 3 commands. Let's have a look at the 3D mesh of the Prophet under the Ultra. Look at this. Look at these details at 8K resolution. I'm going to use it, guys, as my thumbnail for the video. Oh my god, like just like that. Beauty. Rendered in 8K resolution. This is not the pre-rendered video. It's rendered with the game engine. Because there is no such a software that can render this type of 3D animation in real time, this type of effects and everything. There is no 3ds Max Studio, there is no Cinema 4D, there is no Blender, because all of this software, they're using a heavily CPU optimized render, when the game engines using the heavily GPU optimized render, and the GPU is, as you can see, 10 times at least faster than CPU. That's why the game engines is capable to render this type of visuals in real time. And this is why the 3ds Max and Cinema 4Ds should be stop being lazy, and they should take this approach. But they don't want to do that because it's a lot of investments, and there is no such a competitions right now. But I'm pretty sure the game engine companies can go ahead and create the competition for 3ds Max or Cinema 4D and put this type of companies out of the business, because their approach is kind of lazy. It's incorrect in 2020. It's using a lot of CPU cores, and this is what you don't need, because the GPU has the Titan RTX has 4,680 CUDA cores versus even the 64 or 128 threads on the CPU. It's still going to outperform it by a good 10 times at least. But in terms of the rendering, a trailing GPU architecture such as Titan RTX is outperforming AMD Threadripper with 64 cores, 128 threads that was introduced to us in 2020 by a good 20 times at least.
It won't let me go that easily. Symbiosis. Gotta break the link.
In terms of the final output of the frames. Of course, they're going to use the different approaches, because the during this video we're using DirectX 11 API right now, but it's impossible to use it for CPU, otherwise it's going to be slow. So they're going to take something else, but still we're going to be at least 10 times faster. So it was the video, guys, as I told you, as you saw it by the FPS. But right now we're back in the game engine. Look at this beauty, the CryEngine 3, the earlier versions running in its pure beauty. Look at this, it's just unbelievable. And the Crysis 3 powered by the later versions of the CryEngine 3 as again, and that CryEngine 3 version was a little bit more advanced and kind of not fully compatible with this CryEngine 3 version. That's why there is no such a lot of modes from the CryEngine 3 to CryEngine 2, and they're not compatible backwards, because the approaches in the CryEngine 3 from the Crysis 2 and approaches from CryEngine 3 in the Crysis 3 is a little bit different, as well as CryEngine 2 using a little bit different approaches. In CryEngine 2 they render in 3D meshes with it can render single 3D mesh with 200,000 polygons. In CryEngine 3, which is the Crysis 2 or especially Crysis 3, CryEngine 3, you cannot render above, I believe, 50,000 polygons per single 3D mesh. The CryEngine 3 will show you the error. I learned that when I played with the CryEngine 3 and as well as CryEngine 5, and oops, let me real quick go ahead and start it over. And CryEngine 5 using the same approach as well. They took it from the CryEngine 3 to CryEngine 5. So pretty much when company releasing the new engines, guys, it's pretty much they having a lot of, okay, right now it's not lagging, guys, it's just my wireless mouse, and just I'm sitting far away from the monitor. It's gigantic monitor. I'm passing through the signal to 4K resolution right now on this monitor, because this 8K resolution 30 Hz device, recording device, cannot pass through 8K resolution signal. But as again, it's just during the recording I'm good with that, but then I can play it just like that on the 8K resolution gigantic screen, which is Q900 Samsung. Yes, it's the first adapter of 8K resolution, so it's only 30 Hz throughout the single cable, and when you're using two cables the SLI is not working. So that's why, guys, the new LG TVs 8K resolution will support with a single cable 60 Hz. But the problem is Titan RTX doesn't support 8K resolution 60 Hz unless you're using the USB-C or a display port. HDMI doesn't support on Titan RTX 8K resolution at 60 Hz. Keep that in mind. But the newer video cards, Ampere GPU architecture, will have even the HDMI that's supporting instead of 2.0B that right now is on Titan RTX, and it was the same thing on the Titan X Maxwell GPU architecture and on Titan X Pascal GPU architectures. I'm pretty sure the Ampere GPU architecture will have the support for the HDMI 2.1 which will support 8K resolution up to 120 FPS. But you can take a different approaches and use some different converters, but as again, you don't want to use the two cables connected to the Titan RTX or to two Titan RTXs, because if you're going to do that, you're not going to be able to use the SLI. Keep that in mind. But maybe in the future Nvidia going to fix this approach, but still in 2020, when the multiple cables connected to a single Titan RTX or to a two Titan RTXs or Titan X Max also, or Titan X XPs, Pascal GPU architecture, Titan X, you cannot use SLI. Keep that in mind. So this is going to be a very crucial information when you're going to purchase yourself the 8K resolution screen, because you want to make sure that it supports 8K resolution at 60 Hz. As the first adopter, you know, I just didn't have no choice if I want to show to you guys the beauty of the 8K resolution, because the 60 Hz throughout the single port was not available, and I get myself Samsung. But if you're going to get yourself 8K resolution TV and use it as monitor, make sure that single cable is support single port on the 8K resolution monitor, supports the 8K resolution at 60 Hz at least. Okay, with throughout the HDMI 2.1 at least. Okay, so you can get a converter and you can go display port to HDMI 2.1. Hopefully this makes sense. I provided the very useful information for you if you want to jump into 8K resolution. Very crucial. Hopefully you were listening pretty carefully. If not, go ahead and rewind this video and listen it again. So now what I'm going to do, before I'm going to show you the information about my system, I will try to switch it to DirectX 9. Hopefully we don't need to reboot, and we need to reboot this. Okay, let's go ahead and reboot the whole deal over here. We can reboot it, and if Ultra is not supported, then I'm going to show you the high. Let's go ahead and do that. So Crysis2, please boot it up. As again, this is the origin version of the Crysis2, it's not the Steam version. Okay, it's booting up in the window mode, good. And I will try to upload this video, guys, for you in 8K resolution as I'm recording right now. And of course at 30 FPS, because I'm recording at 30 FPS right now. And I'm recording right now at 860 megabit a second bitrate, which is the crystal clear. Completely crystal clear. And I will try to upload it in this bitrate if the video will be above 110 gigabytes, and 40 minutes of the video always above 110 gigabytes. YouTube is not going to accept that. Then I'm going to recompress it maybe to 150, 200 megabit a second, just to make it 100 gigabyte video file size. As you can see, guys, a lot of time, money, energy is invested. Okay, we can play Ultra DirectX 9. Let's go ahead and check out that Ultra DirectX 9. And please don't forget to smash that like button for time, money, as a compensation, motivation for me to create more great videos. All what I'm asking, just a like button and be positive, be great on my YouTube channel. Keep watching it. So Ultra preset, good, good, good. Let's go ahead and try to do it again, the same approach. First level, second level, just like we did it. And as again, this is the Ultra, you saw the FPS, but this is under DirectX 9 API. And under the DirectX 11 API, they're using some advanced shadows, and they're using some complex tessellation approaches by the Crytek company in CryEngine 3 under the Crysis2 game. Keep that in mind. So the FPS should be a little bit higher than under the DirectX 9 API than under the DirectX 11 API. Hopefully, guys, this makes sense. Okay, the GPU utilization is still 99%, so it doesn't matter if you're running window mode or full screen mode, it's still 99%. This is the maximum. The maximum can be 100%, but 1% you're losing about 40 CUDA cores when we're 99 versus the 100%, 40 CUDA cores. An advantage of the single Titan RTX video card versus the RTX 2080 Ti video card is 256 CUDA cores. Everything else almost the same. It's still using the same architecture, the same approaches in terms of the GPU, but only the CUDA cores and the Neuron cores, the tensor cores is a little bit higher in the Titan RTX versus the RTX 2080 Ti, but we are not using the tensor cores when we are playing at least Crysis2 game. It's not optimized for the tensor cores. In the future, there's a possibility we're going to use some tensor cores throughout the real-time rendering just to utilize them. But right now, there is no such a games, as I know at least. 99% of the games in 2020 not using the tensor cores. So your advantage when you're using Titan RTX in 8K resolution or any resolutions when your will be 256 CUDA cores when your GPU utilization at 99-100%. When it's 98% or 99%, a single percent loss under the GPU utilization is equal to 40 CUDA cores. Okay, so if you're utilizing like 95% of your GPU utilization on your Titan RTX, means that you just lost 200 CUDA cores, and 94% GPU utilization under the right top will equal to same performance as RTX 2080 Ti utilized at 100%. Keep that in mind. So in this type of scenarios, when the RTX 2080 Ti is utilized at 100%, it will be equal to my Titan RTX stock when my Titan RTX is utilized at 94%. Hopefully this makes sense. But when RTX 2080 Ti utilized at 100% will be not at stock, will be overclocked to 2.1 GHz on GPU and around 15 or 1600 MHz on a VRAM, because it still comes with the 14,000 MHz as the Titan RTX, because they're using the same GDDR6 Samsung memory. Then the RTX 2080 Ti video card can take an advantage and be even a little bit faster than Titan RTX running at stock. Hopefully guys this makes sense. So the utilization of the GPU makes a big sense in terms of the when you're comparing Titan RTX versus the RTX 2080 Ti video card, and you should take it as consideration. So as you can see guys, I'm providing a lot of multi-angle information, no matter what background you're coming from, PC hardware enthusiast, PC overclocker, graphics designer, PC gamer, you're learning a lot throughout my videos. So don't forget to smash that like button for my support. As you can see, my channel is heavily underrated, and I believe this is the fault of the YouTube, because this is what they do. They pretty much do not put me under the YouTube search, and I search it throughout the different computers of my friends and then see my videos. So they do it in purpose. So only your support, your share with some multiple people can help to push my channel forward, can get me to produce more great videos in the future. And as you can see, my videos are unique. I'm not trying to be like a copy monkey or marketer like all those guys copying each other, providing the same information, or they providing the information that you already heard from somebody else, and they providing to you again and again, so you will believe it's like a truth, but it's not the truth. A lot of those marketers do not cover a lot of great information about the products. As you can see, nobody covered the Titan RTX to you like I did over the iPlay4k.com YouTube channel, or over the iPlay16k.com YouTube channel, or over the UHDking.com. Pretty much the purpose of the Titan RTX, guys, is to play games at the 8K resolution and above. The purpose of it's pretty much using almost the same GPU as RTX 2080 Ti video card, but the big advantage of the Titan RTX is that big frame buffer, 24,000 megabytes of frame buffer, 24 gigabytes of that frame buffer, and it's fast, it's beautiful, and it's giving you the ability to play above 8K resolution or 8K resolution at comfortable frame rate without any lagging or stuttering, like it wasn't possible before on the 4 Titan X Maxwell GPU architecture. It was a little bit of stuttering at 8K resolution at 50% of the games, or even at 2 Titan XPs wasn't possible as well. And I believe the VRAM is not only the feature that give you the advantages in 8K resolution and above on the Turing GPU architecture. There is also the 6 megabytes of the level second cache on the GPU. That's very crucial as well. So VRAM and second level cache on the GPU, so it's shared between those CUDA cores, is very big advantage and benefit for you when we're talking 8K resolution and above, because the higher second level, the higher second level cache the CUDA cores can use, the higher performance, the faster they can render, they can pretty much cache it faster and stuff like that. Hopefully this makes sense. So we're still above 20 FPS and we're still at very high latency delay. So pretty much DirectX 9, switching from DirectX 11 to DirectX 9 doesn't make too much sense, as you can see, for the Turing GPU architecture. It used to be a big sense when we were talking like Radeon 7000 series video cards, when the ATI owned that before the AMD purchased that and ruined the whole ATI Radeon video cards. When we were running like GeForces,
It's all I can do for any of us.
6000 series, 8000 series. No, it was GTX 200 series during the Crysis 2 when it was released. 200 series, I believe. Yep, and 400 series GTXs by Nvidia. The 8000 series was during the Crysis 1 PC game in 2007, 2008, and GTX 260, 270, 280, 275, 290 dual video cards, the first dual video cards by Nvidia. You probably remember that. Was amazing in 2010, 2011, and this is where the Crysis 2 pop up.
Symbiosis.
So guys, I'm going to cover a lot: Crysis 1, Crysis 2, Crysis 3. In all kind of different resolutions. So if you're a fan, just go ahead and keep watching. There's going to be a lot of information, and a lot of information covered throughout the Pascal, Maxwell, and Turing GPU architecture over the iPlay4k.com YouTube channel. You just want to watch it all. And I also covered the old school, the best Radeons video cards like R9 290s in 4-way Crossfire, Quad Crossfire, the last video cards, as well as Radeon Pro Duo, the last Fuji XT, I believe, the last video cards that was able to run Quad Crossfire and was kind of competing, the last video cards that was actually competing with Nvidia before AMD is ruined the whole ATI company and the whole Radeon brand. Right now Radeon is garbage, guys, and yeah. Guys, I purchased the Xeon E5 2097 V2 version 2, and I'm going to use it as my networking render farm, and maybe it's going to also, it's 12 core 24 threads, and maybe I'm going to get 2 of them in dual socket. Well, we're going to find out. First I want to test it on X79 Dark series motherboard. It's going to be beautiful. Look at these visuals, guys. The visuals is still amazing even under the DirectX 9 API, and it's a little bit different rendered, and actually DirectX 9 API doesn't look that bad. It's look a little bit different, but also the visuals is beautiful. 26 FPS, but still below 30 FPS, a tool chart, 8K resolution on a single Titan RTX video card. But as again, oops, I missed that again. But as again, we can play that with the 2 Titan RTXs video cards or with the 2 RTX 2080 Ti video cards, and FPS will be almost double, guys. So, and I'm going to demonstrate it to you over the different video. Keep watching, stay tuned, and I'm going to share with you about that Xeon E5 experience. I'm just going to record and share with you the whole project, and I think this is going to be the best value in terms of the network rendering farm for any YouTuber. I'm looking with the 2 Xeon E5 2697 V2 in the double socket. I'm looking to beat the Ryzen 3950X that cost like $750, and 2 Xeon E5 2697 V2 cost total $300, and I can utilize my old equipment, which is I have 2 X79 motherboards. I have Gigabyte X79 UG3 version 1.1 is definitely supported, because I saw the people was recording video on that motherboard on the same CPU, hopefully with the F11 bias they were stating. So hopefully it's going to be supported. Hopefully this is not naysayers and not misinformers. And I know that X79, which is much better motherboard in terms of the overclocking, Dark Series by EVGA, having some issues with the E5s. But as again, maybe it's just a misinformers, maybe it's not. And I'm going to report it to you back, guys. I just right now ordered the CPU. It's coming and it will be at my house in about a couple days, and it's going to be beautiful. So I'm going to start reporting on that project, and if it's going to be successful, I'm going to share the whole project with you. So okay guys, ultra preset, DirectX 9, not a big difference. The visuals are still beautiful, and I didn't see actually that we were breaking the, no, we're still breaking right there. See that kind of circuish particles, kind of sprite or plane. They just rendered the texture on the plane, I believe. Let me show you the water under the DirectX 9. It's still beautiful. And even under DirectX 9, as you can see API, we still have tessellation in the water. The water is tessellated. And Crysis1 PC game in the DirectX 10 API, the first game that introduced to us the tessellated water. But then Motors brought the tessellation water into the DirectX 9 API under the Crysis1 PC game as well, under the modes. It's looking beautiful, guys. So the Crysis, the Crytek company tried to market the DirectX 10 API by Microsoft, saying that tessellated water is only possible under DirectX 10 and Crysis. So they did it on purpose like that. But the problem is, it wasn't the case. And with the command, we still brought the DirectX 9 API with the tessellated water in the Crysis1 PC game. So sometimes company misinform us, as you can see, and this is one of the examples. Hopefully guys, you're enjoying my videos. A lot of great values, a lot of information. I'm not like, as you can see, I'm commenting and I'm providing the information for you from the experience point of view, not like one of those, the firm, graphics firm or factory, digital factory, whatever it is. There is a lot of nonsense they're saying over there throughout, they're commenting throughout the game technologies. I can definitely say that these people never developed, never played with the game engines heavily, and even the 3D rendering in real-time softwares, because the information that they're providing, they're probably reading somewhere, and some information is very hilarious to me at some point. Okay guys, let me real quick go ahead and open you the whole level right there, the open source. So you're gonna see the FPS will be the same, and I'm going to wrap up with this video. As I promised, I'm going to show you my computer hardware specification information real quick before we're going to wrap it up. And in the end of this video, of course, I'm going to show you a beautiful include for you in the end of this video beautiful videos for you to watch after. If you don't see it in the end of the screen of this video, just go ahead and check the video description or check the video comments. As again, please stay positive guys. And I know there is adrenaline benchmark in Crysis2, but it doesn't work when you're switching between the presets like high and ultra. That's why I decided not to use it. Hopefully this makes sense. Look at this. Render of the glass physics is still here under the CryEngine 3 in the Crysis2, so it wasn't introduced to us in the Crysis 3. Keep that in mind. I just showed it to you on purpose. And those guys, like the AI, as you can see, is like kind of not advanced yet. And there's still games in 2020. They're still not using the proper approach to the AI. They can right now they can utilize the tensor cores if the game is designed in 2020, but they're not doing that. And they can create a very advanced AI, but they're not interested in that, because after the 2012, the game developers, all what they do, they just pretty much the milking the cache, and they're releasing the games after games after games. After that new sandbox theory introduced throughout the game engines, it's easy to do now, and they're just milking the money. They're not providing any values to us, and this is unfortunate. Let me show you some nice fight real quick over here, and we're just going to find out how well the FPS will be down, and if it's going to be down or not by too much throughout the, as you can see, a lot of and the CPU utilization as well as going to get higher than 50%, but it's not. So pretty much, as you can see, guys, in 99% of the games, 6-core, 6-thread CPU in 4K resolution and above is Gucci. Only when we're talking, look at this dude, I just completely didn't hear any shots, nothing. Only when we're talking the Battlefield 5 or Battlefield 1 PC game, as again, even the 8 threads, 8 physical threads, even physical threads, I'm not talking about the hyper trading technology threads. 8 physical threads is not enough in Battlefield 5, guys. In Battlefield 1 it is enough, but in Battlefield 5 it's not enough to run the game with the maximum FPS. It's still lacking some threads, keep that in mind. And you need to have at least 10 thread CPU. It could be virtual threads mixed with the physical threads, but as again, with the physical threads, 10 core CPUs, you're going to receive much better performance, because 3 logical threads is equal 1 physical thread, keep that in mind. So 3 logical threads from the hyper trading is equal 1 physical thread of the core, the real core. So of course, if you're playing Battlefield 5 with 10 physical cores, what I find out in that particular 1% of the games, at 4K resolution, you gotta have 10 physical cores for the maximum possible FPS. Or you can have 10 logical cores, it's still going to be Gucci, but as again, with 10 physical cores, you're going to receive a little bit higher FPS, keep that in mind. When you're playing 4K resolution, I'm talking the 4K resolution, and when you're playing the 1080p, you gotta have 1080p, you gotta have, guys, 12 core resolution physicals, 12 physical cores. You can be Gucci with 12 threads, which is premix, physical and logical, but with the 12 physical cores, you're going to receive a 1080p, the maximum FPS. As again, doesn't matter what kind of video card you're playing, it's just the way the game engine utilizing the CPU, okay? Hopefully this makes sense. But above 4K resolution, like 6K resolution, 6 physical cores and 6 physical threads, like I'm running right now, in Battlefield 5 is more than enough, guys. 6K resolution is, again, I'm talking that Apple Pro Display XDR monitor resolution, 6016 pixels by 3368, I believe, or 64, yeah, 3364 pixels. That unusual 6K resolution by Apple, 16 divided by 9 aspect ratio, and above 6K resolution, you will need even less physical cores and even less the threads, logical or physical or premix, keep that in mind. So the higher resolution, the less threads you need in PC games under the real-time DirectX 11 API, DirectX 9 API, Vulkan API during my test, and OpenGL API. They kind of using the same approaches. You need the less, keep that in mind. The higher resolution, the less CPU threads you need while you're rendering in real time. When you are using the approach such as 3ds Max or Cinema 4D, the higher resolution, the more threads you need. But it's not the case in terms of the game engines, because game engines is optimized for the GPU cores more than the CPU cores. Okay, and when the higher resolution, the more GPU cores is utilized. The game engine is trying to avoid to use the CPU cores, because it understands that CPU cores will give you not any good when you're running 8K resolution or above 4K resolution. Hopefully, guys, this makes sense, and this approach is completely makes sense for the software developers that develop those APIs, and they use the clear sense approaches. Alright, guys, that's pretty much it. I showed you everything what you need to see. Hopefully you saw above 50% CPU utilization, but I have a big doubt. Go ahead and rewind, look at the right top. A lot of action was going on, a lot of AI was doing, and a lot of CPU utilization. Alright, so I showed you over here everything what you need to know. Let me shut down the game real quick, and we're going to go ahead and talk about I'm still recording, that's good. It's still recording under the Crucial 2TB MX500 SSD that I just received. It's plenty of space, 2TB, even for 8K resolution, 30 FPS. But right now it's like 50 minutes of video. Hopefully I'm going to upload at 860 megabit a second bitrate, so it's going to be crystal clear for you to watch 8K resolution on YouTube. If not, then 150, 200 megabit a second compression. So what I was using today, let me go ahead and pull up everything. and I'm going to pull up everything over here. Let me show you the latency delay of this memory, which is amazing, by the way. So we can talk. Okay, so as you can see, guys, I'm number one, 47 nanoseconds. This is the best result for the CL9 2400 MHz, that CL9 aggressive approach in terms of the latency timing, and 1T command, CR1, which is 1T command. Okay, means 1T command. 6 cores, 6 threads, 5300 MHz per each core, per each thread, which is the physical cores, by the way, as I told you, and motherboard Asus ROG Maximus 11 here Wi-Fi model, Z390 chipset. My Titan RTX was running PCI Express 3.0 at 16 times. Titan RTX only supports 3.0 PCI Express. 1200 MHz, which is 2400 MHz as external frequency for our DDR4. CL9 1T command. Beautiful, guys. I'm going to record a video tutorial how to overclock this memory or any memories to this type of frequencies, the stable kind of timing. Don't miss it over the iPlay4k.com YouTube channel. And this memory was DDR4 5000 MHz by Corsair. So 2500 MHz times 2, 5000 MHz. As you can see, XMP 5000 MHz, CL18. But look at this, they're saying it's DDR4 2066 MHz, and I have a little bit doubts about it, that this is not the 5000 MHz actually. And they're using the micron technology stick, because I have a doubt, because I even couldn't keep it stable at 4000 MHz on any Intel boards. The previous Corsair memory was keeping like 4500 MHz, was keeping even on the Z370 with the i5 8600K. I was running 4000 MHz at CL13. Okay, with the 4000 MHz CL19 it wasn't stable, so I decided to go 2400 MHz, okay, and with very aggressive timing. Okay, dual channel, as you can see. So people are saying that Corsair is not using micron chips under DDR4 5000 MHz. Ignore them, guys. And it's 1.5 volts DDR4 5000 MHz memory. Keep that in mind. It says under the CPU that I'm using TU102-300 chip of the GPU of my Turing GPU architecture on my Titan RTX, but it's not the case. It's a TU102-400A, so it's not reading the proper information, but it's reading the information from what Nvidia providing. So Nvidia released a new version of the Titan RTX, but they never told it to nobody, and hopefully this version is a great overclocker. Okay, but I have a doubt that this is a great overclocker, because I'm having some issues when I'm overclocking this video card, even when I'm running liquid metal. So 24 GB GDDR6 Samsung, beautiful memory, can go up to 16,000 MHz stable. This is how great this 6-core 6-thread score. 3700 points result under the multi-thread benchmark, and CPU-Z is multi-thread benchmark. The CPUs that I'm going to show you in a second, I will beat them all in terms of the PC gaming, guys, in any games, with the 6-core 6-threads when we're talking 4K resolution and above, except the Battlefield 5. But in terms of the multi-threaded workstation benchmark, let's go ahead and have a look. This is the archiving benchmark. And look at this, the single thread performance is a big, guys, big difference when we're talking about the performance of the overall CPU of all the cores, overall performance. The single thread performance is very crucial. And my multi-thread ratio performance 5.86 times, so almost 6 times, which is a great utilization of the 6 cores under this frequency. And this is under the version 17.0.64. Let me real quick go ahead and compare with you. Look at this. 36 thread, ba-bam. Okay, this is the 18 cores, 36 thread, 2 times faster than me. Okay, but not 2.5 times. Okay, and he's using 36 thread and I'm using only 6 threads, so he's wasting a lot of threads under the, and this is the multi-threaded benchmark. So as you can see, those threads, especially those virtual threads, not scaling great. And based on my utilization and my approaches and my tests, my benchmarks, I find out that 3 hyper-threading threads from the Intel Core i9 generation, it could be changed throughout the newer Intel generation, but 3 hyper-threading virtual cores, virtual threads, is equal 1 real physical core, or 1 real physical thread. Keep that in mind. And as you can see, AMD even not that even worse than that. This is the Ryzen 16 thread, guys, and the Ryzen 16 thread not even 2 times faster than my 6 threads, so you can see the quality of this Ryzen 16 thread. And of course I'm running the overclock each core, but I'm running only 6 threads, 6 core, and he's running 8 core 16 threads, not even 2 times faster, 1.7 times faster than me with the 16 threads under the multi-threaded benchmarks. But under the PC gaming, I'm going to destroy that CPU completely. It's not going to be faster at anything in the PC gaming. Keep that in mind. I'm going to go ahead and scroll the CPUs right now. Go ahead and press pause. Am I recording? I'm still recording this. 1 second, guys. Yep, okay, I'm still recording. 59 minutes. Wow. Go ahead and press pause, use my methods and approaches. Let me show you. Today I'm going to disappoint the 8 Gen i7 owners. 12 threads, 6 core 12 threads versus my 6 core 6 threads. So 12 more, 6 more threads under this i7. And I'm beating it, guys. I'm beating it in multi-thread performance, okay? So you can see the single thread overclocking per each, the overall CPU performance on all cores will give you absolutely amazing results. You just want to have as high as frequencies as possible per each core, especially when we're talking PC gaming. In PC gaming, I'm completely going to destroy the CPU, but under the multi-threading workstation benchmark, I'm destroying the CPU as well. And this is the legendary CPU, by the way. I have the 8600K, guys, i5 with 6 core 6 threads running 5 GHz. Go ahead and check it out with 2 GTX 1080 Ti video cards, and it was amazing. Another legendary CPU, 7 Gen i7. Look at this, 4 cores, 8 threads. I'm dominating purely in the multi-threaded benchmark. In the PC gaming benchmarks, I'm going to just destroy the CPU. Legendary 2600K, I used to have it at 4.2 GHz. Look at this, double. I'm dominating by more than double. And this is 8 threads. So the generation between the CPU that didn't bring me that much of the performance over those 8 threads, but the frequency which has pretty much brought me that performance. Hopefully this makes sense. Wolfdale, very legendary CPU. I used to have it at 4.2, and I have some videos over the iPlay4k.com YouTube channel. Look at this. I was running 4.2. I'm dominating it in multi-thread performance by 6 times at least, 6.5 times, and single-threaded performance almost by 3 times. This is how fast today I'm running, okay? What else? Let me real quick go ahead and go with you over the IDA 64. Go ahead and keep your eye. This is with the CL9 1T command 2400 MHz. Pretty much the fastest possible scenarios of DDR4 technology under the Core i9 Gen CPUs. You can see comparing to different CPUs how I compared. I just destroy in terms of the latency that 3950X with 3600 MHz, like by 20 nanoseconds. The lower nanoseconds in terms of the nanoseconds, the better in terms of the latency. I will bring it to you in a second, show you how I destroy the 3000 series Ryzen with the way faster DDR4 memory. Okay, and let me show it to you. Latency delay. Let me see where, right here, the Ryzen. Look at this. I'm by 20 milliseconds faster. The lower value is better, okay? And he's using CL16 3600, very expensive memory. I'm destroying that. And keep in mind that you don't need to buy DDR4 5000 MHz to be able to run these frequencies. I will try to clock 3000 or MHz or 3200 MHz CL16, CL14 memory to these frequencies. I will try to show it to you. But watch my tutorial how to do it, and you can try it with your memory. If you cannot reach CL9, go ahead and try CL10 or maximum CL11 for that aggressive timing and for the maximum performance boost on your CPU, okay? What else? Real quick, the IDA right here, 47% of overclock, beautiful, 53 multiplier for the external frequency and 48 multiplier for the AVX instruction, running completely stable today. DDR4 2400 MHz 9 12 12 43 1T command CR1. Look at this. Try to match me on the latency delay. This is unheard of latency delay for the DDR4, guys. This is like kind of DDR3 latency delay for the very low timings, but this is DDR4, this pumping frequency. Look at this. Try to match me, okay? You can beat me of 3600 MHz in terms of the read, write, and data and copy performance. There is a possibility, but try to match me under the long term. You're going to pretty much benefit from that 3600 MHz. But in the PC games, when it's short, nice, fastest latency delay at the timing, I'm delivering a great result. I'm 20 nanoseconds faster than Ryzen 3000 series. The CPU, by the way, that costs more than my CPU i9-9900K, and I'm not even running 8 cores, 16 threads. So this value can be especially level 1, level 2, level 3 cache multiplied by the cores. So when I'm running 8 cores, 16 threads, I'm way above 2000 gigabytes per second on level 1 cache transfer, right? Read and copy, keep that in mind. So what the IDA 64 version 6.20.5300 does, it's pretty much testing the single thread performance, and then it's multiplying times threads. Okay, this is how it's getting the data. This is how they do. So you can outperform me with more cores under the level 1 cache read, write, and copy data, but try to outperform me in terms of nanoseconds. Okay, 10.9 nanoseconds, 2.3 nanoseconds, 0.8 nanoseconds. When I'm running 2 cores, 4 threads, it's unheard of. When I'm pretty much emulating my i9-9900K at 2 cores, 4 threads, my latency delay is 45.8 nanoseconds that I saw on average. Can you believe it? It's running 5.4 gigahertz for my CPU, 2 core, 4 threads. And level 1 cache even 0.7 nanoseconds, which is unheard of for the 9th gen Intel CPUs. And level 2nd cache 2.2 nanoseconds, and level 3 cache is 10.6 nanoseconds with the 5.4 gigahertz stable, completely stable. It's only stable on the 2 cores, 4 threads. It's not stable 4 cores, 4 threads. It's crashing, but 2 cores, 4 threads, it's stable, and I'm going to record you a video to show it to you guys. It's just unheard of results, okay? And real quick, the IDA 64, before I will let you go, GPU, when we comparing the Titan RTX versus this CPU at this overclock, and as again, the Titan RTX was running stock. Let me show you MSI Afterburner real quick for those naysayers at 100% fan rotation, completely stock frequencies, okay? So this is the scenario, same algorithms, but Titan RTX running OpenCL, which is a little bit harsh for the Nvidia GPUs. For the Nvidia video cards, they're more friendly for the AMD video cards like Radeons and stuff. And the CPU is running the optimized x64 machine code, heavily optimized, which is unheard of results for the CPU when we compare it to the GPU. Okay, and yeah, this is what's up. So pretty much this is the CPU benchmark, but have a look just at the data transfer so you can get an idea for your own analysis and stuff. Alright guys, that's it. That's it. I showed you everything what you need to know. And as again, let me real quick and show you guys that 6 megabyte of, so CUDA cores was 4608, not 680, but still 250 CUDA cores more than RTX 2080 Ti video card. This is the level 2nd cache. 6 megabyte is very crucial when we're talking the 8K resolution comfortably and above, okay, on the GPU. So when it's spreading throughout this CUDA cores, it's better performance throughout the computing. Okay, and of course 24 gigabyte of memory size of VRAM is the best because you need to store that into the frame buffer. Okay, hopefully guys this completely makes sense. Thank you so much for watching. Right now I'm putting some great videos for you to check out. Don't forget to support me, smash that like button, share it with your friends, positive comments. Have a great day, and I will see you in the next videos. I play 4K, aka I play 8K, aka I play 16K, and my new nickname UHDking, because I am the UHDking. I showed you the first 16K resolution gameplays back in May of 2016 on my 4 Titan X Maxwell GPU architecture, and it was Half-Life 2. Thank you so much for watching. Till the next time, stay tuned. Great videos are coming out.